Find the point closest to the 3, -2 on y equals x squared minus 4x plus 12. From pre-calculus, you should automatically say, hey, I'm looking for the closest point on this parabola. That's what a parabola, that's closest to this point. And two things. Quick sketch. First of all, from pre-calc, we can say, hey, I can put this into the general format. You don't have to do this, actually. You can put it into the general format and know where the vertex is, because then if you graph this little situation, we know that the vertex is right here. You notice I didn't even label it until just now. The vertex is what? 2, 8. And my point A is 3, -2 is down here. And some point on this curve is xy. And I want to find that little green distance that's shown right here between these points. I want to know that point xy. I want to minimize that, right? So this is an optimization problem, nothing to do with time, not a related rate. Again, I don't memorize the distance formula. Every time I have one of these cases, I make a horribly drawn right triangle. I'm looking for the distance between point xy, an ordered pair 3, -2, which gives me d squared equals y plus 2 quantity squared plus x minus 3 quantity squared. And again, the trick with these distance problems is always the same thing, guys. Listen carefully to how I say this. I know if I minimize d, I will have minimized d squared. So I can say, hey, instead of dealing with this disaster of d squared, right, I can change it to, I'll minimize the distance squared, which is going to help me by getting rid of some of the stuff. And I want to optimize, but I have to have one variable. Right now I have 2. But when you have these type of problems, if I find it again, you have a K and Nancy, hey, you got y equals a bunch of junk right there, right? Y equals all that stuff. So I'll put the stuff in here. Y equals x squared minus 4x plus 12 plus another 2 is plus 14. And now I have an equation with one variable that I can say to you guys straight up that, hey, I want to find where d is the smallest it can be. Once you say that, what do you want to do? Take the derivative and set it equal to 0, because you know it'll be a min or a max. So I'll do that. I'll get d prime equals chain rule 2 times x squared minus 4x plus 14. All right. Times the derivative, yucky, 2x minus 4 plus 2 times x minus 3. And again, the inside of this is 1. I want to make sure you guys realize we did the chain rule twice. This is a cubic. This becomes a cubic. All right. This is a great time for us to talk about how to use our calculators. I don't want to solve this longhand, do you guys? All right. So we're going to get out our TI-84 calculators. All right. And we're going to plug in. Does everybody agree I want d prime to be 0? All right. We can use our solver. All right. I'm going to pause the video for a second and get out my calculator, take a picture of it here. All right. So again, when we use the solver, you need to write solver T84. We set d prime equal to 0, which is entering all this stuff under the solver, which is under math, saying, hey, this all equals 0. Tell me the value. Oh, calculator of mine. And when I did that, it said, hey, x equals 2.0. 476. 3 decimal places. 4 decimal places. Guess what I just found? I just found the value of the x-coordinate on the parabola. And if I want to find the point, all right, I now have pretty easy work, because we know that parabola is x squared minus 4x plus 12. Watch how Mr. Anderson's going to cheat, because I don't want to take time during class anymore. If I want to find the point now, There's the ordered pair. Does everybody agree? X comma Y. That is not AP worthy. You guys would actually have to put that in your calculator and get an answer, which I'm not going to do at the moment. But let's be clear. This is the point. How do we know that this is going to be a minimum? We could do it by finding the second derivative of this. Does everybody agree? We could, but except I also know that this has got to be a minimum. Okay, and you guys from practice are done. We should all know this. And again, I suppose I could take 2 seconds here and get the right answer and let the video be an extra minute long. So 2 point, because the picture tells me so. Hey, you say that, but that's not a bad way of saying it. You know, you're given that equation. And, oh, how close to the vertex is this point? Holy cow. Which makes sense if you think about it. And there's the answer. And if I do this as there is the answer. And we have just optimized a point to a parabola. And it's an ugly one. Now, everybody, this would be unsolvable for us without using a TI calculator. You can't do it long-handed. No, it would take us too long. All right, this is optimization. This is most of the AP. All right.